Hello and a very good day to fellow academics. Today, I, Muhammad Nasrullah, together with Shuzlina, Abdul Rahman, and Yuzi Mahmud from Universiti Teknologi Shah Alam, Malaysia, wants to present a paper on violence recognition using convolutional neural networks. Cisco predicted that by the year 2022, 82% of the IP traffic of the World Wide Web will be video traffic, which 17% of them would be live videos. According to Interactive Advertising Bureau IAB, about 70% of digital device owners globally watch digital content at least once per day. This statistic clearly indicates that live stream videos are becoming today's world's norm. And the availability and the ease of access of live streams have both great benefits and risks. Live stream videos can be very beneficial, such as in online education and work from home environment. However, live stream videos can also be a platform to spread violence, such as in April 2017, Stephens have murdered a black man and live streamed it on Facebook Live. And also the Christchurch mosque shooting during Friday prayer was also live streamed through Facebook Live in March 2019. This research is a small step to ensure a safe live streaming environment for everybody. Concurrently, it helps parents to supervise their children browsing of the World Wide Web, such as children without a supervision can be influenced with violence action that they see while browsing the internet. This is crucial because children are more likely to be influenced, uh, than adults because they learn through observations. Also, this research is a small contribution to achieving the United Nations Goal 16 of Sustainable Development Goals by eradicating any forms of violence. From the title of this paper, the main task that we want to achieve is to detect violent actions in live stream videos. Since videos are just images or frames bundled together, we want to detect actions in each frames or these images. Thus, the task that we need to do is image classification or action classification in these images. So previous studies have shown that convolutional neural network is the network to go when dealing with image classification. Classic artificial neural network limits the use of deep hidden layer and not suitable for image classification, as this network will overfit easily with big data. Also, convolutional neural network could reduce the number of parameters and an artificial neural network would need. Thus, help researchers to approach large models with complex tasks. CNN is also proven to have excellent performance in machine learning problems, especially applications that deal with big image datasets. Existing studies of action detection models can be categorized into four types. The first one performs classification at frame by frame or segment level and then match the predictions into detection results. The second one is a proposal-then classification framework. It is implemented by generating or proposing a set of boxes on frames that are likely to contain an action, then classify the proposed action. The third one is a single string framework which is based on single shot object detectors. And the fourth one is a deconvolution layers on top of full convolutional network to ensure the output length is the same as the input video length. In this paper, the scope of violent actions in interest are punching and kicking actions. For that, there are several datasets that we use to get the data. The first one is Kinetic 700. Kinetic 700 is a collection of 10-second videos of human actions gathered from YouTube videos. These datasets have around 700 classes of human actions. So from those 700 classes, video with classes of punching bag, punching person, wrestling, side kick, high kick, and drop kicking are in interest. From that videos, and then the frame of those videos are then extracted with setting of 10 frames per second, and each image that this extraction produced will be filtered to make sure the training of the model to be as efficient as possible. And then the final amount for the dataset is 1,281 kicking and 1,309 punching images. Then for another action of other, so that the model can differentiate between violent and non-violent action, we use standard 40 action datasets that also have human action image dataset. So 221 images are chosen for this class of other action. In this project, training and testing were done on 3 CNN off-the-shelf models with transfer learning strategy, which means that the pre-trained weights are used so that to reduce development cost and time. The 3 CNN models are VGG19, Mobile Net version 2, and Inception ResNet version 2 models. The input images dataset that I explained earlier are split into training and validation with the ratio of 75% and 25% respectively. The parameters for all models are kept constant. A learning rate schedule was also implemented to reduce the learning rate by 0.1 factor when no best new validation loss is found after 20 epochs. Okay, let's now see how these three models do with the task that we want to do. For VGG90 model, from the confusion matrix, we can see that this model has a minor confusion to differentiate the three classes of actions. And VGG90 model seems to have problem in differentiating between kicking and punching the mouse. For MobileNet version 2 model, from the confusion matrix, we could see that this model has a difficulty to differentiate between the three classes of action. This model often mistaken kicking and punching as a non-violent action. For Inception ResNet version 2 model, from the confusion matrix, we could see that it performs slightly worse from VGG19 model. This model confuses the most in differentiating punching and kicking from other action. By comparing these three models, it is clear that VGG19 models is the most accurate and has the least loss. There are several theoretical reasons that explain these results. The first one is that every neural network architecture has different optimal hyperparameters to be initialized for good results. Since in this paper, all these three models use the same hyperparameter settings, this result is not very accurate. Essentially, the neural network with high number of layers are good for high number of class problems. But since this in this paper there are only 3 classes, this model with high number of layers, high number of layers, high number of layers, will have problems in performing this task. That's all for me. Thank you.